doing a couple different experiments here, and we're going to be on page 10 of the probability packet. And we're going to look at a situation today that's involving flipping for dish duty. So we're going to start out with one event where we're flipping a coin, and then we're going to look at another type of event where we're flipping a cup, and we're going to see if the thing we flip affects the decisions we make about doing the dishes as a chore. So we have two people. We have Ayana and we have Barb. Ayana and Barb. Okay. So Ayana and Barb are sisters, and they've been given the chore of washing the dishes after family dinners. So it's either Ayana or Barb. Mom and Dad are out. Ayana would like to flip a coin every day with Barb to decide who will do the dishes each day. For each day in the month of June, record the results of the sisters' coin flips. So there are 30 days in June. So June has 30 days. So that means if Ayana does the dishes, we'll say Ayana does the dishes. If it's a heads, we'll give Ayana heads, and we'll give Barb, we'll say that she does the dishes if there's a tails. But we'll keep that 30 in mind because that might be helpful when we're making our predictions. Before flipping the coin, how many days would you expect Ayana to do the dishes? Now remember, this is called a theoretical probability. This is what we think is going to happen before doing the experiment. So how many days would you expect Ayana to do the dishes? Well, there's 30 days in June. The probability of picking a heads is 1 out of 2. So that would mean out of 30 days, we would expect her, how would we get from 2 to 30? We'd multiply by 15. So if the probability is 1 out of 2, we're saying that we expect her to do the dishes for 15 days. And that would mean Barb is tails. That's also 1 out of 2. And that would also mean that we'd expect that she would do the dishes for 15 days. This is our theoretical probability. This is what we'd expect to happen. Hopefully it works out that way. It says, why do you think your predictions are accurate? So our predictions are accurate because our predictions are based on the theoretical probability of getting a heads or tails. So we're using our knowledge of probability that there are two possible outcomes. One of them is heads, one of them is tails. And, we're thinking that about 50% of the time it's going to be heads, 50% of the time it's going to be tails because those are equally likely. So now we're actually going to do the experiment. So on the bottom of the page, we're going to do the experimental. We're going to figure out our experimental probability by actually flipping a coin. So you don't see these questions yet. That's on the next page. But I'm just going to write the word experimental here because the experimental is actually following through on the experiment. We're hoping it's going to be close to the theoretical. Well, we'll see. So I have a coin here. It's a interactive digital coin, but it's a coin nonetheless. And we're going to use this coin to figure out who does the dishes, Ayana or Barb, for each day. So we're going to flip it 30 times. And we'll write down the probability for each one. First, heads. That's Ayana. Then we got heads again. Also Ayana. Heads again. Oh my gosh, Ayana. Heads again. That's 4 heads in a row. Then a tails. Finally a tails. Another tails for Barb, doing the dishes. Another tails. We're getting some streaks here, looks like. Another tails. So 4 heads in a row, 4 tails in a row. Let's see if it's different. Still tails. Another tail. This is very unlikely that we get this many in a row here. Now a heads. Here we go. Another heads. Another heads. Jeez, going on quite a run here with these heads and tails. Another heads. It's an H. Tails. Heads. Heads again. Tails again. Tails. Tails. Heads. Tails. Tails. Heads. Tails. This is very exciting. Tails. Tails again. Heads. Heads. And let's see what the last day is. Heads as well. All right. Thank you, Coin. Appreciate what you did for us there. All right. Let's take a look at this. So we're going to look at this in sections here. So the first section we're going to look at is what was the fraction to represent the coin being heads during the first 10 days? So here are the first 10 days. So how often was it heads? We had 1, 2, 3, 4 heads out of 10. All right, the coin was tails. Well, let's look at tails. The first 10 days, if 4 of the 10 were heads, 6 of the 10 were tails. Coin was heads during the first 20 days. Now we're looking at the first 20 days, which is going to be 1 through 20. So, whoops, that should be a heads there. First 20 days. Let's see how many heads there were. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, well, that worked out. 10 out of 20 were heads. So I'm just going to double check this just to make sure, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 were tails. That's nice. So now we're going to take a look at this during the month. So there were 30 days in the month, so it's going to be out of 30. This is also out of 30. Heads during the month. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Wow, 15. So that means 15 were tails. Now this should say tails. Oops, that should be 15. All right, it says after you kept flipping, did the fraction of heads and tails get closer or farther from 1/2? Well, you look here, when we started, these weren't exactly a half. We got heads less than half, we got tails more than half during the first 10 days. But as we went on, you can see that after 20 days, it was exactly half. And after 30 days, it was exactly half. So we could say the fraction got closer to a half. The fraction got closer to 1/2. And typically that's what happens, that as you do an experiment like this, the more and more times you flip the coin, the closer you're going to get to 1/2. Doesn't always work out perfectly like it did here, but typically or usually that's what happens. It gets closer to 1/2. Let's check out some other questions here. We got, if the sisters continue to flip for the rest of the year, how many days would each sister likely do the dishes? All right, so there are 365 days in the year. So 15 out of 30 was what we got at the end, which is the same thing as 1 out of 2, 1 out of 1/2. We're trying to get to 365. Well, that's an odd number, so we might say, maybe it's a leap year. We'll say 366. So how can we get from 2 to 366? It would be half of that. So what we can do is we can just divide 366 by 2, and we'll see what we get. So this will tell us about how many times each person will have done the dishes. A lovely chore to do. Sorry, I'm kind of getting in the way of the next question, but should be 183 times. So 183 times. It says explain your thinking, and the reason why is because each sister would wash dishes about half the time. All right. Just going to pause here for a moment. I have a special guest, and I'll be right back momentarily. Thank you for your patience. Okay, I'm back. During a school week, Ayana ended up only having to do dishes 2 times. Find every other way Ayana could have flipped the coin during the week and only washed the dishes twice. All right, so we're going to look at different possibilities here. We have Monday, Tuesday, Wednesday, Thursday, Friday. Okay, so one way, because I remember Ayana, this is one way to do it. Ayana has 2 heads Monday, Tuesday, and then the rest are Wednesday. So here's another way she could have done it. If she got heads on Monday, she could have got tails on Tuesday and then heads on Wednesday. Tails on Thursday, tails on Friday. Or she could have got heads on Monday, tails on Tuesday, tails on Wednesday, heads on Thursday, tails on Friday. Look at how I'm going in order, kind of like in an organized way to find the answer here. I'm starting on Mondays and then seeing what would be the next day she could get another heads. Tails, tails. She get tails on Thursday and then heads on Friday at the end of the week. Or she could get tails on Monday, heads Tuesday, heads on Wednesday, tails Thursday, tails Friday. So we're seeing how many different possibilities are there for Ayana to do the dishes twice in a school week. Or we could do twice Tuesday. Tails Wednesday, heads Tuesday, tails Wednesday, heads Thursday, tails Friday. I'm just going to scoot down a little bit here. Or we can do tails Monday, heads Thursday, tails Wednesday, tails Thursday, heads Friday. Those are all the possibilities with Tuesday because we already had Monday and Tuesday. So now we'll look at what if she gets heads on Wednesday. Tails Monday, tails Tuesday, heads Wednesday, heads Thursday, tails Friday. I think there's only one more, or there's 2 more possibilities. Tails Monday, tails Tuesday, heads Wednesday, tails Thursday, heads Friday. And I think the last one is, because that's all of them for Wednesday, if she started getting tails or heads on Wednesday, would be she gets tails on Thursday, heads on Thursday, heads on Friday. Those are the only possibilities. So there's one up here that we counted. This is the second one, third one, 4, 5, 6, 7, 8, 9, and 10. There they are. Okay. It's the end of the day, so I'm going to pause it, and I'll be back in a second.
Attention students,
right.
Nicholas Cutlip, please come to the main office.
Well,
Nicholas Cutlip, please come to the main office.
So I'm just gonna, yep.
They don't want you to do that.
Yep. I'm just gonna talk about this answer real quick. So it says, how did you know that you found every way? And we did it like this in an organized way, so that we knew we counted each one. We could have just randomly picked 2 days where she would have had to do the dishes twice, but instead we did it organized when we went from each day one at a time to see what our the possibilities for her washing the dishes twice in a week, school week. All right, here's the next situation. Unfortunately, we won't be able to do the actual experiment for this, but I did it with a couple of students earlier today, and I will report the results to you. So on the next page, it says marshmallow toss. We're going to change the word marshmallow to cup. And we're going to change that word marshmallow to cup. Every time you see the word marshmallow, change it to cup. Which is nice because cup is not a long word. We're going to change marshmallow to cup. Because we used cups instead of marshmallows because you don't get marshmallow stuff all over the floor. All right. So Ayana does not like to do the dishes. Well, who does? I kind of do a little bit. She's trying to find a different object to toss to give her a better chance of not doing the dishes. Ayana decides to test out large and small cups. So what a couple students did is they tested out flipping a large cup and a small little tiny cup. So I'm going to report the results to you now. Where it says they each tossed the cups 50 times, and I kept track of their data. With the large cup, landing on an end, meaning it landed like on the top or the bottom of the cup. When they flipped the cup onto the desk, the large cup landed out of 50 times, it landed 10 out of 50 times on an end, on the top or the bottom. It landed 40 out of 50 times on the side. Okay? The small cup, it landed 32 times out of 50 on an end, and it landed 18 times out of 50 on its side. So now we're going to take a look at some questions based on the data that we collected. So it says, number one, test each size cup. What size should she use? Well, looking at these numbers, remember, she does not want to use the dishes. So I would think that she would want to use the large cup. And you might be thinking, why is that? Because she doesn't want to do them. So the cup that she could pick to allow her to do the dishes the least would be the large, because this probability is the smallest probability of the four. So if she picks the large cup and says, like, I'll do the dishes if I land on an end, 40 out of 50 times, she will not have to do the dishes. So which cup should she use? Large, because it lands on its side. What would that be? 40 out of 50 times. So if she picked the side, like, I'll do the dishes if it lands on its end, or I don't have to do the dishes if it lands on its side, that would be a good decision. Lands on its side 40 to 50 times. Okay. So which landing position should she choose to represent her doing the dishes? She would choose lands on an end. Because more often than not, it's going to land on its side. So if she chooses landing on its end, that would be good for her, because it only comes up 10 out of 50 times or so. Which cup would be a good choice for Ayana? Why or why not? Well, we kind of already explained that. She'd choose the large cup because if she flips that one, she will only do the dishes because remember, if we keep flipping, it might change a little bit, but about 10 out of 50 times. You'd think after a while Barb would catch on and be like, listen, this cup's not fair, but you never know. You never know. So based on this experiment, we'd think Ayana would pick the large cup because it has an advantage for her here. If she picks landing on its side, meaning she won't do the dishes, then that will give her a higher probability that she will not do the dishes. All right. Well, if you want to do the experiment with marshmallows at home, go ahead. Feel free. But we're going to stick with the cups. Hope you had a great day. If you have any questions, please let me know. If not, I'll hope to see you soon. Have a great day. Bye-bye.